Transcription factors are not activators, and they are not repressors. That language is convenient, but it is scientifically misleading. Let me start simply. Take the letter O in the word go. It contributes to movement forward, right? In the word stop, it contributes to stopping. Is the letter O an activator in one case and a repressor in another? Of course not. The letter has no intrinsic meaning. Meaning emerges from combinations of letters, from structure, from the context. Only words carry meanings, not letters. And yet, in molecular biology, we routinely say, this transcription factor is activators, and this is one a repressor, as if a single binding event contains direction. It doesn't. A transcription factor rarely acts alone. It binds within a regulatory architecture with other transcription factors, with co-activators, co-repressors, mediator complexes, chromatin remodelers, histone modifiers, cell type-specific epigenetic states, everything else. The final outcome, activation or repression. It is not a property of a single factor, it's a property of the assembled complex. Just like meaning is not a property of a single letter, and we know this. The same transcription factor can activate in one context and repress in another. So what this changed? Not the protein. The regulatory word changed. The motif architecture changed. The cooperative partners changed. The chromatin environment can change. A signaling state change, everything changed. The system, the whole system is changing, yet we keep the binary label because simplification is so comfortable. Binary categories feel safe. But biology is not binary, it's cooperative, context-dependent, not linear, combinatorial. The activator-repressor paradigm was historically useful, but once we entered systems biology, once we began modeling composite modules, once we analyzed enhancer grammar, this framework became insufficient. If we continue thinking in binary terms, we will continue misinterpreting complex regulatory logic. At TransFac, activation versus repression was never the central axis of curation, not because it's irrelevant, but because regulatory direction is not an intrinsic property of one factor. What matters more is the binding site, the motif cluster, the composite module together, the validated cooperative interaction. Regulatory meaning emerges from the structure, not from isolated labels. This is not simple semantics. It affects how we interpret ChIP-seq, for instance, how we perform promoter analysis, how we infer upstream regulators, and even how AI model and modelers learn regulatory logic. If we encode static polarity into these models, your conclusions inherit that simplification, and those simplifications will propagate quietly, systematically. When I explain this to students, I return to the letter analogy. The first they smile, it sounds simple and some ridiculous, but when they understand, then the questions lands. Why would we assign semantic direction to a single letter? So why do we assign regulatory direction to a single transcription factor? If we want mechanistic understanding, we must think in terms of regulatory grammar, combinatorial syntax, context-dependent assemblies, but not isolated factors. If you are working on promoter modeling, enhancer analysis, upstream reconstruction, AI-based motif inference, and you feel that activator-repressor language no longer matches your complexity or complexity of your data, you are probably right. Let's talk. Click the first link below the video. Briefly describe what you are working on. We'll explore how curated regulatory knowledge from TransFac can help structure your analysis and clarify the causal mechanism behind your data. Because the problem is not your data, it's a reductionism. It's reducing cooperative regulation to a single factor role. If your scientific case is particularly complex with many different omics data, and you would prefer to discuss it with me directly, briefly outline your situation and we will arrange a Zoom meeting and examine it together in depth. Because transcription factors don't act alone, regulatory meaning emerges from architecture of their cooperation. I am Alexander Kell, and perhaps it's time now we move beyond simple labels and start finally modeling regulatory complexes.